Sushmita. Have we ever imagined what is the way by which we can extract metal from the earth crust? How can we refine them? Let's go to find out the answer in this video. Before starting, let us revise the previous session once more. The compounds of metals that occur in nature along with the impurities are called minerals. The minerals from which the metal can be separated economically are called ores. Ores contain many types of impurities such as soil, sand, and rocky substances along with the metal compounds. These impurities are called gangue. The process of extraction of metal in its pure state from the ores is also a part of metallurgy. Learning outcome: extraction of highly reactive metal, extraction of mid-reactive metal, extraction of low reactive metal, electro-refining, corrosion and its prevention. Keywords are reactivity series. Arrangement of the metals in decreasing order of their reactivity is known as activity series. Calcination. Calcination is usually done to carbonate and oxide ores. Refining. The process of obtaining the pure metal from the impure metal is called refining of metal. Gangue. Ores containing many types of impurities such as soil, sand, and rocky substances. Let us look at the concept map of today's lesson. Extraction of the metal from its ore depends on the reactivity of the metal. To understand the order of reactivity of metals that are very familiar, we study their chemical reactions with cold water, steam, dilute, and strong acids, and based on their vigorous activity in these reactions, we frame out activity series. Arrangement of the metals in the decreasing order of their reactivity is known as activity series. The metals like potassium K, sodium Na, calcium Ca, magnesium Mg, and aluminium Al are so reactive that they are never found in nature in free state. The metals like zinc, Zn, iron Fe, lead, Pb, etc. are moderately reactive. They are found in the earth crust mainly as oxides, sulfides, and carbonates. Metals like gold, Au, and silver, Ag, are the least reactive and they are found even in free state in nature. Based on their reactivity, we can arrange metal in the descending order of their reactivity as shown below. The metals at the top of the reactivity series are highly reactive. Their reactivity decreases down the series. For example, potassium, sodium, aluminium are reactive metals. Reactive metals have large capacity to form cations by losing the electrons in their outermost shell. For example, the reactive metals react vigorously with dilute acids to give hydrogen gas. Highly reactive metals burn by reacting with oxygen from air at room temperature. Their extraction has to be done by electrolytic reduction. For example, the metals sodium, calcium and magnesium are obtained by electrolysis of their molten chloride salts. In this process, the metal is deposited on the cathode while chlorine gas is liberated at the anode. The electrode reactions during the electrolysis of molten sodium chloride gets metallic sodium. The metals in the middle of the reactivity series such as iron, zinc, lead and copper are moderately reactive. Usually, they occur in the form of their sulfide salts or carbonates. It is easier to obtain metals from their oxides rather than sulfides or carbonates. Therefore, the sulfide ores are strongly heated in the air to transform them into oxides. This process is called roasting. Carbonate ores are strongly heated in a limited supply of air to transform them into oxides. This process is called calcination. The following reactions occur during roasting and calcination of zinc ore. The zinc oxide so obtained is reduced to zinc by using a suitable reductant such as carbon. Apart from carbon, reactive metals such as sodium, calcium, aluminium are also used as reducing agent for the reduction of metal oxide to obtain the metal. This is because these metals displace a moderately reactive metal from its compound. For example, when manganese dioxide is ignited with aluminium powder, the following reactions take place. The heat evolved in the above reaction is so large that the metal is formed in the molten state. Another similar example is the Thermit reaction. Here, the iron oxide reacts with aluminium to form iron and aluminium oxide. The metals at the bottom of the reactivity series of metals are less reactive. That is why they are found in free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2s. Copper is obtained from Cu2s ore just by heating in air. The metal obtained by the reduction of the ore is usually contaminated with impurities like unchanged ore, other metals present in the ore, and non-metals from the anions in the ore. The process of obtaining the pure metal from the impure metal is called refining of the metal. Some refining methods are given below: distillation, poling, Liquation, electrolysis, distillation. This method is very useful for purification of low boiling metals like zinc and mercury that contain high boiling metals as impurities. The extracted metal in the molten state is distilled to obtain the pure metal as distillate. Poling. The molten metal is stirred with logs poles of green wood. The impurities are removed either as gases or they get oxidized and from scum slag over the surface of the molten metal. Blister copper is purified by this method. The reducing gases evolved from the wood prevent the oxidation of copper. Liquation. In this method, a low melting metal like tin can be made to flow on a sloppy surface to separate it from high melting impurities. Electrolytic refining. In this method, the impure metal is made to act as anode. A strip of the same metal in pure form is used as cathode. They are put in suitable electrolytic bath containing soluble salt of the same metal. The required metal gets deposited on the cathode in the pure form. The metal containing the impurities goes as the anode mud. We use this electrolytic method to refining copper. For this, an impure copper is taken as anode and pure copper strips are taken as cathode. The electrolyte is an acidified solution of copper sulfate. As a result of electrolysis, copper in pure form is transferred from the anode to the cathode. The soluble impurities go into the solution, whereas the insoluble impurities from the blister copper get deposited at the bottom of anode as anode mud, which contains antimony, selenium, tellurium, silver, gold, and platinum. Recovery of these elements may meet the cost of refining. Zinc may also be refined in this way. The rusting of iron, iron oxide, tarnishing of silver, silver sulfide, development of green coating on a copper, copper carbonate, and bronze. Some of the examples of corrosion. Prevention of corrosion is of prime importance. It not only saves money but also helps in preventing accidents such as a bridge collapse or failure of a key component in machines due to corrosion. One of the simplest methods of preventing corrosion is to prevent the surface of the metallic object to come in contact with the atmosphere. This can be done by covering the surface with the paint or by some chemicals. Examples: bisphenol. Another simple method is to cover the surface by other metals, Sn, Zn, etc. that are inert or react themselves with atmosphere to save the object. This is generally done by electroplating. An electrochemical method is to provide a sacrificial electrode of another metal like Mg, Zn, etc., which corrodes itself but saves the object. What we have learned today? The method used for extracting of crude metal are calcination, roasting, chemical reduction, auto-reduction, displacement method, electrolytic reduction. Calcination is a process of heating the ore strongly in the absence of air or oxygen. During calcinations, carbonate of a metal is converted to its oxide. Roasting is a process of heating the ore strongly in a free supply of air or oxygen. Calcination and roasting are carried out in a reverberatory furnace.